ওঠে না। আমরা বিভিন্ন সময় দুটো কোয়ান্টিটির রিলেশন দেখার জন্য, তার যে প্যাটার্নটা দেখার জন্য আমরা গ্রাফ প্লট জেনারেলি এতদিন আমরা কি করতাম, হাতে ইন্ডিপেন্ডেন্ট কোয়ান্টিটিকে অ্যাক্সিসের বরাবর রাখতাম আর তার রেসপেক্টে যেভাবে চেঞ্জ হতো ওয়াই ডিপেন্ডেন্ট কোয়ান্টিটিটা সেটাকে ওয়াই অ্যাক্সিস বরাবর প্লট করতাম। কিন্তু ব্যাপারগুলো প্রচণ্ড টিডিয়াস এবং হেক্টিক হয়ে যেত, তাই আমরা সফটওয়্যার ইউজ করতে শুরু করেছি। আধুনিক সময়ে আমরা যেহেতু আধুনিক হয়ে যাচ্ছি, সেখানে আমরা মূলত আমাদের কোর্সে Gnuplot আমরা ইউজ করি, অথবা আমরা পাইথনের স্পেসিফিক ম্যাটপ্লটলিব যেটা আছে সেটাও আমরা ব্যবহার করতে পারি। এই লেকচারে আমরা মূলত ফোকাস করছি Gnuplot'ের উপরে। তো আমি অভিনন্দনকে বলেছি, সে একদিনই রাজি হয়েছে বলার জন্য কিছু। তো থ্যাংক ইউ অভিনন্দন, ওভার টু ইউ অভিনন্দন।
Hello guys, welcome to this wonderful channel Juvenile Gurukul. As you all know, on the occasion of 3rd anniversary of this channel founded by my dear senior Avinandan, we are delivering some lectures on some really interesting and unique topics. And so today I am going to throw some light on a very useful tool for physicists as well as mathematicians, which is plotting. And specifically for this course I will be focusing on Gnuplot. In this course we will be covering the topics which are as follows. Now, what is Gnuplot? Gnuplot is a free and open source plotting software that can be used for creating graphs, plots and charts. It was originally developed to visualize scientific data and to see the increase or decrease of those data with respect to some parameters. Now, why we use Gnuplot? Gnuplot is a very versatile and flexible software. It has a very user-friendly interface. Besides, it also gives us the opportunity to generate high-quality 2D and 3D plots with minimal effects and high accuracy. Gnuplot provides a powerful set of tools for creating and customization of plots. Users can specify plot styles, colors, labels, and annotation to create visually appealing and informative plots. These plots can be used in books as well as in presentations. Gnuplot is such a powerful tool that we can customize each and every corner of the plot. One of the most useful features of Gnuplot is the ability to plot functions as well as equations. Users can define their own mathematical expression and plot them on the graph as their data, allowing for easy comparison and analysis. Now, to begin with, we will start some basics of 2D plotting with an example. Now, here's an example with a code. To plot in Gnuplot, we have to use the keyword plot. In here, we have plotted a cos function, a sine function, and a tan function. After the plot keyword, we mention the x range and the y range. Here, we have taken the x range as 0 to 10 and y range as -5 to 5. The cos function here we have taken as line points, and the sine function as lines, and the tan function as points. The cos function has line color 3, the sine function has the line width 4, and the tan function has the point type 6. These customizations are very important in this Gnuplot. To get a very good and accurate plot, we need accurate and also a beautiful plot. We have to customize this with these keywords. Now here the set axis, the set 0 axis shows the x-axis and the y-axis on the plot. The x level and the y level respectively represents the what data we are plotting on x-axis and y-axis respectively. The set title helps us to name the plot. Here, as we can see, I have named the plot functions, which has overridden the previous line cos function. So Here we can see all those things. Here this is the sine function, this is the cos function, this is the tan function. Here we have named the plot functions, y-axis as y-axis and x-axis as x-axis. Now as we can see here, the points have their gaps. These gaps can be increased or decreased using some customization and a keyword that we will use later. Now what is this gap represents? This gap represents the sampling rate. Sampling rate is the number of points per unit x-axis or y-axis. Now the higher sampling rate will produce more accurate plots, but will take longer. These parameters have no effects on data file plotting. Like we can see here, to have a sample rate 50, we have set the sample, we have written set samples 50, and to set the samples 500, we have written set samples 500. With the function exponential to the power minus x by 100 into cos x. And to set the sample rate 5000, we have set the sample rate 5000. Now here's the sample rate is 550. So you can see the plot is not so accurate. It's not near also accurate. And here in 500 plot you can see it is very accurate, and in 5000 it's very accurate, but nearly we can see here the accuracy is similar to the 500. After a certain point we attain the saturation level, after which the accuracy doesn't depend on the ISO rate. Now here's the parametric plotting. A parametric plot is one in which a function or expression is plotted against another function or expression using same independent variables. In 2D plot we use only one parametric variable, and in 3D plot we use two parametric. For 2D plot, Gnuplot recommends the 2D parametric element as t, and in 3D plot we use u and v as parameters. Now to plot parametric equation we have to set the Gnuplot as parametric, or command it to set the Gnuplot as parametric. Then we have to plot two equations simultaneously, like t and t to the power 2. This, as you can see, is a plot for a parabola. We can also plot this using x to the power 2. Now why we are using two equations instead of one? This arises due to the complications of higher equations, which we will see later. Now here, as you can see, to plot this we can't have regular simple equations. We have to use parametric forms. Here I have used this function to plot this heart. Now similar to parametric plot, we will be using polar plot. Now what is polar plot? The polar plot representation is the graphical representation of complex number, or the complex plate. The polar plot is obtained as the locus of real and imaginary plot of a complex equation or complex number. In the polar plane, the coordinates of the polar plot are real and imaginary plots of a complex number. Now here we can see we have set the sample as 500, which is not necessary, but we have done that. Now we have set we have commanded the Gnuplot to use polar equation, so we have used set polar. Now we have plotted a function with the theta of the polar function ranging from minus 2 pi to 2 pi, and radius ranging from minus 3 to 3. And now we are using the function t into sin t with line width 2. Now you can see that here is a locus of all the points. It's a beautiful curve with wings like structure. Now in polar mode, the independent dummy variable is denoted by t, the angle. Angle represents the plane polar coordinate. Here is an example of polar plot. Here's in this example we will see our iterative structure also. In these functions we have used the iteration for n equal to 1 to 5. Here the function is 1 plus cos n which is the iteration variable. This we have used with product of theta. Thus the result as a flower. Here n represents the every petal of number of petals of the flower. For first this violet there is only one petal, then the green we have two petals, then the blue we have three petals, for the brown we have four petals, and yellow we have five petals. Now here comes the interesting part, creating 3D plots with Gnuplot. In addition to 2D plots, Gnuplot also supports the creation of 3D plots. These plots allow users to visualize data in 3 dimensions, providing a more comprehensive view of the data. Gnuplot supports a variety of 3D plot types like surface plot, mesh plots, and contour. Thus, in this lecture, we will only see surface plots and also a little bit of contour plotting. One of the advantages of using Gnuplot for 3D plotting is its ability to create interactive plots. Users can rotate and zoom in on their plots to explore the data from different angles and perspectives. Now, here's a 3D plot. We have a sphere and a paraboloid. A paraboloid is a 3D structure of a parabola. For sphere, we have used parametric equation to plot the 3D plot. Here we have set the parametric equation and then given the u range as 0 to 2 pi and the v range as minus pi by 2 to pi by 2. We have set the radius of the sphere as 3, and then we have the 3 parametric equations. Here the PM3D depth order functions helps us to represent the plotting in 3D way. And here in the parabola we have used the Cartesian equations to plot the parabola. The Cartesian equations for a paraboloid is x square plus y square. Now here we can see the plotting. Here the sphere with the depth order here represents the different depths or the values of the function with the increasing or decreasing order of the color. Why is Gnuplot or any kind of online plotting softwares? Compared to hand plotting, Gnuplot offers several advantages. First and foremost, Gnuplot is much faster and more efficient than hand plotting. It allows users to generate high quality plot with minimal efforts and freeing up time for other tasks. In addition, Gnuplot provides greater flexibility and customization option than hand plotting. Users can easily modify plot styles, colors, labels, and annotations to create visually appealing and informative plots that meet their specific needs. In hand plotting, we can also see the width of the pencil or the grid size also have an obstruction to our precision. Here's an application of Gnuplot. We can use Gnuplot to map the Earth surface as a 2D surface. Now, how you can do it? We can do it using contour lines. A contour plot is a graphical technique for representing a three-dimensional surface by plotting a constant Z slices called contours on a two-dimensional format. Simply, it's just a projection of the 3D surface on the 2D plane. Now, how to use contour lines? To use contour lines, we have to set the samples as well as the ISO samples to accordingly. Then we have to use the command set CNTR PARAM levels to 40 or the thing we wish. This helps us to specify the number of contour lines we want to get. Then we have to set contour, then plot a 3D plot. Like here we have plotted XY. This is the graph. As we can see, there are 40 different contour lines with respect to the CNTR PRM levels. Now, applications of Gnuplot. Gnuplot has a wide range of applications across many fields, including science, engineering, finance, and data analysis. It can be used to create publications quality figures for scientific papers, or to visualize data in business presentations, or to analyze data in research projects. One particularly useful application of Gnuplot is the creation of animation. By generating a series of plots and combining them into a video, users can create dynamic visualization that help to convey complex concepts and ideas. Now, here is an application of Gnuplot also. I have given a project on Newton's ring. We have to plot this data on Gnuplot. So, I use the table and the data to plot, and here's the result. As you can see, here's a beautiful representation of our data, and fortunately our data also matched the values of the actual wavelength. Now, concluding my presentation with a brief description. Gnuplot is a powerful and versatile plotting software that offers many advantages over hand plotting. With its ability to generate high quality 2D and 3D plot functions and equations, it is also creative and interactive and supports a wide range of data file formats. Gnuplot has become an essential tool for many fields. Whether you are a scientist, engineer, financial analyst, or a data scientist, Gnuplot can help you visualize and analyze your data quickly and efficiently. Thank you.